My name is Kainton, the Tech Pro, and in this lesson, I'm going to show you how to build all these classifiers step by step with no step skipped. So the focus will be to build classifiers, and we are going to be using the Titanic Dataset. Let me show you the Titanic Dataset. It's just a CSV file, and this CSV file contains the attributes of the passengers who were in Titanic, who survived, who did not survive, based on the name, the sex, the passenger class, and so on and so forth, the ticket fare. So basically, this classification we are going to be doing, these classifiers, you're actually going to be using it to predict who survived and who died. Or if there's another Titanic that happens at this time, who will survive and who will not survive. So this is based on a number of things like the passenger seat or the class and so on and so forth. So this can actually help you decide if you are boarding a ship or a vessel or a cruise to know how to be safe. So let's just go ahead to get started. In case you would like to learn more, please hit on the subscribe button to subscribe to my channel so that you don't miss any update. We are going to be looking at 7 classifiers. If you have any other one you would like me to talk about, please let me know in the comment box below this video as well. And please like and share. Decision tree, random forest, naive Bayes, gradient boosting, k-nearest neighbor, logistic regression, support vector machine. We are going to be also checking which classifier is actually the best based on our data set. So I'm going to actually, these are marked down cells, so we don't have to worry about them. So the first thing we want to do is to import pandas, numpy, and seaborn. Now seaborn is used for visualization. I'm going to be talking about it a little after now. So I'm going to import all these. Pandas is used to manage data frame, and NumPy is used to do some calculation or arithmetic. So the first thing we want to do is to import the data set. So there is the data set location in my local drive. So I'm going to say separation is tab and engine is equal to Python. So it does a little cleanup for us in this data set. So what I'm going to do now, we've imported it, so I'm going to kind of insert a cell below, and then I'm going to simply say df.head. So let's just take a look at this data set. Maybe we'll look at 10 of them. You can see it's imported and it arranged perfectly well, as you can see. So we have passenger class, survive, P class, and so on. So the one thing we want to do is to drop name ticket. Actually, the name does not help us determine if the person survived or he did not survive. So we are going to drop this the name. We are also going to drop the ticket and as well as the cabin as well. The cabin, we are dropping it because there are a whole lot of missing values there. And we cannot use it because the missing values are just too much that if we drop all the missing value rows, we'll have very little data. So the best thing to do is to drop the column cabin and also drop ticket and drop name. So to do that, simply say form an array of columns to drop and simply say df.drop and specify the column to drop. Specify the axis is 1, meaning along the columns. So I'm going to run this, so it drops it. So if we say df.head again, you can see that those columns are gone. So name, ticket, and cabin are gone. So this is what we have right now. So to check whether there are null values, because null values are actually a problem in analysis, to check whether there are null values, we are now going to use seaborn. So seaborn.heatmap df.null helps us to see in a graphical form where there are null values. So I'm going to run, and now it tells us that so this is where we are. Okay, so it tells us that the age contains several null values. Now we are going to replace these null values by using the method called interpolation. So basically interpolation is saying that if there are two ages, that is, let's say 15 and 20, it means if there is a row that is in between, therefore that will be between 15 and 20. So in that way, it's going to fill up all the missing values using interpolation. And this is what I do here using df_age is equal to df_age.interpolate, and it's going to fill the missing values. Okay, so we've done that. So if I run the heat map again using seaborn, you can see there is all the missing values has been interpolated, and now we have one single missing value in embarked. So we can actually just simply drop it by using df.drop na to simply drop it. So I'm just using the interpolate, I'm using drop. I could actually have dropped those missing values, but I'm just trying to let you know that there are different ways you can clean up your data. So I'm using drop not available Can also use interpolate to handle it. So in this case, since it's only one, I'm going to simply drop it by saying df.drop NA, and that is going to be fine. So if I say run, we have, this is what we have. Let me just show you one more thing. You can also say something like, let me insert a new cell below. You can also say df.info, and that's going to give you some information about your data set. So it's telling us a number of things about this data set. We have embark is an object. So this one that is an object is a problem. It's not a number, so it's going to give us problem when we're analyzing. So we are going to find a way to manage this object to change it either to a float or an int. So to convert these categorical values S, C, and S, and also male, female, we are going to convert male, female to 1 and 0, and also convert these to maybe 0, 1, and 2. So to do that, we are going to create dummy columns for the column you want to convert, then concatenate it with the data frame, then drop existing column. So let me just show you how it works. So the first thing we are going to do, let me create dummy columns. So if you create dummy columns are created. To simply view the dummy columns, I'm going to kind of insert a cell below, and at this point I'm going to say df.head. So I want to show you how dummy columns has been added right here. So sorry, okay, so it's not been added. So dummy columns are created but not added for now. So I'm going to add it by running this in this case. So if I say df.head, now you can see dummy columns, male and female. So basically it's on marshalling what values we have in this set. We have male, female. It simply create a column for them. And also in case of embark, we have SC and Q. It simply creates new columns for them. And you can see, and these columns are now numeric. Now we can actually now drop this embarked column and also this sex column, because we have actually unpacked it into several columns, dummy columns that are numeric. So let's now drop sex and embarked. So I'm going to run this, and they are already dropped now. So now I'm not going to preview. Separate the data frame into X and Y. Now we have survived. This survived is actually the target variable. That's what is called the dependent variable. So we are trying to check who survived and who died. So actually this survived, you see here, is actually the Y. And passenger ID, PCLA, is X1, X2, X3, and so on. So we have only one Y. So we have X is equal to df.values and Y is equal to df survived.values. So we are separating into X and Y, where Y is survived and X is every other thing. So I'm going to run it. Now we have X and Y, but take note that X contains everything. So for X, we are going to delete the first item. So we have, in case of X, we have 0, 1. So X is, we are going to delete survived from X, right? So we are deleting the survived column from X, okay? Now this very index column does not count. So I'm going to run it to delete, and now let's now go to the main work, building classifiers. And for us to build a classifier, the first thing we want to do is to split our data set into text and train data set. In this case, we are splitting it into 70% training set and 30% text set. So I'm going to run it. The split module is the train text split, available in sklearn.model selection. So let's start building the first one. The first one is decision tree classifier. You import it from sklearn.import tree, and then actually building the classifiers are all done in the same way. Simply say dtclf. There is the name of my classifier. You can give it any name. It's tree.decision tree classifier. Specify the max depth. You can actually increase this if you want, and then fit the data sets. So when you are fitting, you're actually training, and then we now make prediction. So this is making prediction, and then we are after prediction, we now check the score of the classifier. So I'm going to click. So we have 78.7% for decision tree classifier isn't so bad. So this is about confusion matrix. I'm not going to be talking about it. So let's move to the second one, random forest classifier. The random forest classifier is also another very good classifier that can be used. So in this case, you are specifying estimators, and we are importing it from sklearn, and also the name of the module containing the random forest is the Ensemble module. So take note of the modules where you have these classifiers available. So it's basically the same thing. Fit it. In this case, fit it using the training data set, perform the training, and then check the performance of this classifier using the text values. So I'm going to run. So in this case, we have 76.7, very close to the decision tree. But for now, decision tree is leading. Random forest is taking second. And now we have the gradient boosting classifier. It's available in the Ensemble, the gradient boosting classifier. So you train, you test. So I'm going to run it as well. Gradient boosting scores low. So you can see we have the decision tree 78, we have the random forest 76, and now we have gradient boosting 70. Now we can actually tune a classifier. Gradient boosting classifier can be tuned using something called hyperparameters. Hyperparameters are simply values that you specify in the beginning of the training of the classifier to tune the performance, kind of improve the performance of the classifier. So in this case, I'm using 40 as the hyperparameter in this case, and I'm tuning my gradient boosting classifier. After tuning, it improves from 70% to 74.5%. So now gradient boosting now improved, but it's still the last compared to decision tree and random forest. Okay. So let's now go to the next one, the naive-Bayes classifier. Naive-Bayes is called naive-Bayes because it kind of makes some random assumptions, initial assumptions. So naive-Bayes classifier is available in sklearn.naive-Bayes, and I'm using Gaussian naive-Bayes. So it's the same thing. NB, the classifier is equal to Gaussian NB. Fit the training data set and check it using your text data set. Let's see what we have here. So we have 76.6, so it's kind of 76.6, just about the same with the random forest classifier. Let's now go to the k nearest neighbor classifier. I'm actually disappointed with this classifier because it's giving me something really very low. So if I run it, you can see it gives me 57.4. Really very poor. But don't worry, after now we are going to check the performance of all these classifiers. I'm going to be explaining it to you after now. Let's now move to the logistic regression. This is a really good classifier. And now I'm going to explain something to you. Meanwhile, let's run for the logistic regression. We have 80.85. Great. I think this now becomes number one. So logistic regression is really very good because it's based on the logistic function, which is really works well for classification based on categorical values. And this is the kind of data we have. So classifiers performs based on the class of kind of data you have. So this logistic regression classifier does not mean that it's actually the best classifier of all, but it simply means that it fits the data we have perfectly well. So if you have this kind of data, we actually should use something like logistic regression. But we are not done yet. We still have another contestant, the SVM, support vector machine classifier. And we are going to use the same method. In this case, we have sklearn.svm import SVC. Make no mistake about it. SVC is uppercase, so it simply means support vector classifier, and I'm going to run it. It gives us whooping 89.3. This is so great, 89.3. So this kind of gaps every other classifier. And support vector machine, you can specify the kernel, it can either be linear, or you can actually take out linear and use the default kernel. So again, I'm kind of going to cut out the linear, and let's use it without specifying the kernel, and I'm going to run. Whooping 97.9. That is so great. SVM leads. You have SVM is kind of the best classifier we can have for our data set. Actually, in the real sense, SVM kind of is one of the one of the best classifiers out there that you can use for classifying for classification problems. Now, I'm not going to go into explaining all this probability, but I'm going to show you the ROC. ROC simply means Receiver Operating Characteristic Curve, that tells you the performance of your classifier, and also we are looking at area under the curve. So I'm going to make another video to explain how to plot this graph, how to create the probabilities, calculate the ROC. You can see I calculated the ROC right here. Just give me 1 second. I can run it again, and you can see support vector machine is leading, have an area under the curve of 0.910. All right, so let's go down. So if you want to learn more, please subscribe to my channel, because I'm going to make another lesson where I'm going to simplify the concept of AUC, area under the curve, and ROC. But meanwhile, let's take a look at what we have here. So we have the line, this blue line. Let me just explain to you the blue line that actually cuts diagonally across the rectangle here, across the curve, is actually a random classification that is made not based on any classifier. So it simply splits the data into two. So it's based on chance, and we are now trying to assess our classifiers or check the performance of our classifiers based on this random chance here. So if you look at this brown line below the blue line, it actually means this classifier has actually done very poorly, because area under the curve, in case of this brown classifier, actually this brown classifier is k nearest neighbor, which gives us 0.425. It performed very, very poorly. And the best one gives us the highest area under the curve, which is that should be the support vector machine classifier at 0.910. All right. Okay, so how do you do all this? I'm going to be making another lesson, but for now I'm going to be stopping here. I would like to thank you for viewing. Please look at the description box, and maybe I'm going to place the data set there, and also place this notebook. But you can actually pause and see the syntax. Actually, this is simply to show you how to build these classifiers using different models available. So I'm going to stop here. Please subscribe to my channel, like and share this video, and let me know if it has been informative for you. I remain Kind on the Tech Pro, and we'll see you in the next lesson.